Right. Welcome to chapter 8 of this UID course. This chapter essentially looks at data analysis, interpretation, and presentation. In the previous chapter, we looked at the various ways in which we can collect data. But once you have this data collected, you need to be able to analyze it, interpret it, and present it. Okay, so the aims of this chapter are to discuss the differences between qualitative and quantitative data and analysis, enable you to analyze data gathered from the various tools, for instance, questionnaires, interviews, observation studies, make you aware of software packages that are available to help you in your analysis of the data that is collected, identify or highlight the common pitfalls in data analysis, interpretation, and presentation, and also to enable you to interpret and present your findings in appropriate ways, as this will be critical, as we'll see in the coming lectures. Okay, so what are the distinctions between quantitative and qualitative data analysis? So quantitative data, as we have seen, in some of the previous lectures, is data that is expressed as numbers. Whereas on the other hand, qualitative data is essentially that kind of data that is difficult to measure sensibly as numbers. So it's the sort of data that you'd get, for instance, through a qualitative interview, where the sort of responses you get will be maybe text-based, if you want. So it's difficult to, for instance, count the number of words to measure dissatisfaction, as just one example. Okay, so qualitative analysis expresses the nature of elements and is represented as themes, patterns, stories. Okay, whereas quantitative analysis has numerical methods that can be used to ascertain size, magnitude, amounts. Because remember, with quantitative, we're dealing with numbers, so these are easy to measure. Qualitative, you're looking at themes, patterns, coming up with stories, user stories, say, for use of a certain technology. Okay, so it's very important that you're careful how you manipulate data and numbers. Okay, so these are just some really simple examples of quantitative analysis. So, for instance, remember we've said that quantitative essentially is about numbers. So when you have numbers, you can easily compute averages, okay? You can compute the medians. You can compute standard deviations. You can also use percentages to do your analysis. However, it's important that you're careful not to mislead with numbers. Then also we can use graphical representations to give an overview of data. Actually, these are really good if you want to present findings, because as I say, a picture is worth 1,000 words. So graphical representations are very good as well, way to represent your data. Okay, so and these are just some quick examples of graphical representations. So an example of the kind of things that you could do, you can present a plot like this one, where they're sort of showing interaction profiles of players in an online game. So this is a really good presentation of quantitative data. Then you have another plot which shows a web page activity, for instance, on a given website. Okay, so these are really beautiful ways in which you can present data that is quantitative. Okay, then you can do all sorts of web analytics as well with quantitative data, and this sort of makes it nice and easy way of presenting analysis results from your numerical data. Okay, so we've seen just a few examples of how you would present or do your quantitative analysis and present using graphs and other and all manner of pictorial presentations. You could use histograms, you could use frequency tables or frequency graphs, use percentages and so on. So, however, if you're looking at qualitative analysis, this is slightly different because what you're looking out for with qualitative data is you're looking out for patterns, you're looking out for themes that are emerging from the data that you have collected. Okay, so one of the other things also is you want to identify categories within the data that you have collected. Okay, you're looking for critical incidents so that you can focus on key events and be able to make some kinds of inferences about the data that you have. Okay, so the picture here, for instance, shows an affinity diagram of an Indian ATM usage. Okay, so affinity diagrams basically are tools that are used to organize ideas and data. Okay, and these affinity diagrams allow for ideas to be organized in groups based on natural relationships for review and analysis. So this is one way in which you can sort of use to group your data, your qualitative data that you may have collected as a result of whatever a piece of study that you might be engaged in. So, for instance, in this case, they are looking at ATM usage in India. Okay, and the results from this can lead to probably a redesign of the ATM and the way it is used. Okay, so it's important to have the mastery of using these techniques to collect and analyze data. Okay, so there's quite a number of tools that can be used to support data analysis. You can use a spreadsheet, simple to use. You can draw basic graphs. I think Microsoft Excel can do this for you very nicely. There are statistical packages, for instance, a statistical package for social scientists that you can use to also do this. Very powerful tools that can be used to derive or present for you all sorts of analysis. Okay, you could do analysis of variance, you could do basic descriptive statistics, and all manner of regression analysis and so on. So it's very powerful tools. Then for the qualitative data analysis, you have tools like NVivo and Atlas that can allow you to code and analyze qualitative data. Then there's also a project called CAQ DAS, based at the University of Surrey, that can also help you in doing analysis of qualitative data. Okay, so you can look that up and try to play around with how those tools work. Okay, so qualitative data, if you're dealing with qualitative data, there are quite a number of frameworks as well that can be used for qualitative analysis. So essentially, the frameworks provide some sort of lenses through which you can view a set of data, okay, and then sort of derive further derive theory from your analysis or from your results that you may have obtained. Yeah, these theories can be quite complex, particularly uh, for bachelor's level, but they're used in research, particularly from masters and onwards, and they're very old theories that have been proven and tested. So what I'll do is I'll just briefly talk about each of these, just to sort of give you an idea of what they are. Then if you're interested, you can dig further into what they're about. Okay, so we have grounded theory, distributed cognition, and activity theory as some of the theories you can use as lenses within which to view or to analyze data that you may have obtained from any given piece of research work. Grounded theory um, aims to derive theory from a systematic analysis of data. So it is based on categorization. Okay, what they also call coding. And within this categorization, there are three levels. There is what they call the open level, where you identify categories. So you have a data set with a lot of text responses that you may have derived from your respondents. So you identify various categories from within the text. Then you do what they call axial coding. So you flesh out and link the various subcategories. Then the selective coding, which essentially helps you form the theoretical scheme or sort of derive some sort of theory from the analysis of your responses. Okay, so in grounded theory, researchers are encouraged to draw on their own theoretical backgrounds to inform analysis. So yeah, it's a very interesting theory. So I've seen this being used mostly in PhD research, and probably just talked about in master's level type research. But these are quite complex theories that are just good for you to know. But later on, if you decide to take a research career, this might be quite useful. Okay, so this is just an example of a codebook that is used in grounded theory. You can do, if you want to dig further into this, you could just um, search a bit more, but that won't be necessary even for the exam. Okay, so this is just an excerpt or some kind of diagram showing what axial coding would look like. Yes. Right, so the next theory is that of distributed cognition, which essentially is a branch of cognitive science that proposes that cognition and knowledge are not confined to an individual. Rather, it is distributed across objects, across individuals, across artifacts, and tools within an environment. Okay, so the theory of distributed cognition was introduced by Edwin Hutchins in the 1990s. And essentially, what this theory is about is that the development of knowledge is attributed to a system of thinking agents interacting dynamically with artifacts. Okay, so this theory has been applied in a number of domains, for instance, within distance learning and also within computer-supported collaborative learning. Okay, again, it might be too complex at this level, so it's just nice to know what it is for now. Okay, then we have what we call activity theory. Again, quite complex theoretical framework. And essentially, activity theory is about who is doing what, why they're doing it and how they're doing it. However, having said that, things are not, or things are rarely that simple. So, activity theory is also sometimes referred to as cultural historical activity theory with the acronym CHATS. And it is grounded in the work of Russian psychologist called Vygotsky and a number of his students. For example, Leontev in the 1920s. So they came up with this theory after a series of researches that they had done in the 1920s. So essentially, activity theory uh, provides you a lens with which you could use to tease out or better understand human activity within an environment. Okay, so what that does then is it allows us as researchers, as students, to then develop a better system. So better systems. Okay, so activity theory um, also looks at an activity as consisting of um, this is what the theory looks like diagrammatically. Engelstrom's activity system model. So essentially, what this diagram is about is activity theory looks at an activity as consisting of a subject and an object mediated by some kind of tool. So the subject can be an individual or a group engaged in an activity. So the activity is undertaken by a subject using tools to achieve an objective, thus transforming into an outcome. Okay, so when you're analyzing this activity systems model, you look at the top triangle first. Okay, where they say a subject who is an individual, group of individuals are engaged in some kind of activity. Okay, the activity is undertaken by the subject using a tool to achieve an object or objective, um, and thus transforming into some kind of outcome. So, activity theory additionally also includes collective activity, uh, community, rules, and division of labor that denote the situated social context within which collective activities are carried out. Okay, again, a fairly complex model that can be used as a lens within which to understand an activity system. So it's, again, just good to know, but if you want to dig further, there's a lot of material online that you can look at. Okay, so we've looked at all these various ways in which analysis can be done, looked at some theory that can be used to analyze our data, our qualitative data. But how do you present the findings? Okay, so there are quite a number of ways in which you can present research findings that arise either from quantitative or qualitative data. Okay, but one caveat to note is only make claims that your data can support. Okay, so it's important that you make claims that can be supported by the data that you have collected. Okay, so the best way to present your findings depends on the audience, the purpose, and the data gathering and analysis undertaken. Okay, so for instance, if you have done a study on how farmers use a certain kind of mobile technology in order to improve productivity, and hypothetically, maybe your sample has been about 10, 15 farmers. you cannot make a claim that all farmers, for instance, if they use this mobile application, they'll increase productivity by 200%. Okay, that does not work because, first of all, the sample is too small, and then it is difficult for you to back those assertions with the data that you have used to derive those results. Okay, so another point is graphical representations. As discussed in previous slides, the best way in which you can present your data. So if you can present plots, visualizations, and so on, that's the best way in which you can present data. Then, of course, there are other techniques that can be used. For instance, using notation like UML. For instance, you can, present your findings as activity diagrams. Maybe derive some interesting use cases, and so on. So the other way is using stories to create scenarios. Okay, and then having some way in which you can summarize your findings. Okay, so just to summarize this chapter, which was fairly short, data analysis the data analysis that can be done depends on the data gathering that was done. So if you haven't done proper data gathering, then obviously your data analysis, will not be as good. Okay, so qualitative and quantitative data may be gathered from any of the three main data gathering approaches. Percentages and averages are commonly used in interaction design. You could use mean, medians, and modes. These are all different kinds of averages and can have very different answers for the same data set. So grounded theory, distributed cognition, and activity theory are theoretical frameworks to support data analysis. Presentation of findings should not overstate the evidence. Okay, thank you very much.